I want to take a few minutes and to talk about working with the half angle formulas. Let me give a brief introduction and explanation, and then we can maybe work through one or two example problems. Here are the half angle formulas for sine, cosine, and tangent. The interesting thing about these half angle formulas, you notice, first of all, their square roots. It's also interesting. For all three of these formulas, the only thing you would need to do this calculation is to know the cosine of the angle. But you notice in front of each of the square roots, it's plus or minus. Now, sometimes in the world of math, when you have plus or minus, you write that because you have two different solutions. And the most common example is if you were looking for the square root of 9 in the world of math, it's very common to write this as plus or minus 3, which means there are actually two answers. -3, square root of 9 is -3, square root of 9 is also +3. Now for these half angle formulas we're going to use here, that is not how this works. In other words, when we're going to use the half angle formula for the sine of the half angle, there are not going to be two answers, plus or minus. There is only going to be one answer. So what we have to do before we ever use this formula, I always, before I start trying to calculate the formula, I need to go in and determine whether my answer is going to be a positive or negative number. So let me show you how we determine that, and then maybe actually work out a couple of problems. So the easiest way is to actually do a problem. So I've pulled up a couple of questions that were assigned in the online homework. Let me see if I can share my screen so I can show you the problems. And then I will write down the information. So problems 3 and 4 up here, they actually ask you for both finding the double angles and the half angles, but for now we're just going to focus on finding the half angles. So for problem 3, so you're given an angle theta, and they're telling you theta is between 0 and 2 pi, which means theta, I like to think of it this way, theta is somewhere in the unit circle. Now they tell us that the secant of theta is 8 and the sine of theta is greater than 0, or sine of theta is a positive number. And then they ask for these things. Now we're looking at part C and D, and actually we don't even need to calculate both these. We'll just look at, say, calculating C, sine of theta over 2. So let me write down the information we're given. Secant of theta is 8. Sine of theta is greater than 0. And then for us, let's just do part C. We're asked to figure out what is the, so let me stop sharing. So here's the information. Secant of theta is 8, sine of theta is positive. We want to know. Now let's go ahead and I'll just write down here the formula for the sine of the half angle from this formula sheet, and it is plus or minus square root of 1 minus cosine theta over 2. So really, if you think about it, to calculate this sine of the half angle, I need two things. If I can figure out what the cosine of theta is, I plug it in here, and then I have to figure out whether my answer should be a positive or negative number. Now for the cosine of theta, here's what I always do. Let's do that part first, and then we'll figure out how to do figure out whether it's positive or negative. I always take the information they give me, and what I like to do, and you've seen me do in the video lectures, is just I take this information and create a right triangle. Now, first of all, I don't normally work with secant, but I know the secant of theta, secant gets grouped with cosine. So if the secant of theta is 8, I know the cosine is the reciprocal of this. You can think of this as 8 over 1. So the reciprocal means you flip the top and the bottom. So basically, I have cosine of theta equals 1/8. Now, what's interesting is, if I'm looking at the angle theta, cosine, let's write it like this. Here's the information they've given me about theta, and based upon this information, I can determine what quadrant theta is in. Right? We have the 4 quadrants. So what I know about when the cosine of an angle is positive, that's going to be either quadrant 1 or quadrant 4. When the sine is positive, that's quadrants 1 or 2. So which quadrant do we have in common? Quadrant 1. So I know that theta is in quadrant 1. So now I'm going to take this information and create a right triangle. Although, you know what? Actually, I don't even need to create a right triangle. You know why? Because for this formula, I need the cosine of theta. And you know what? I already have the cosine of theta. So in a minute, I'm going to plug in 1/8 in here for cosine of theta and then do this calculation. But now I need to go ahead, and before I do that calculation, I want to see whether the sine of this half angle should be a positive or negative number. And what I do is I start out by looking at which quadrant angle theta is in. And I'm going to write this as an inequality. So once again, just make sure everybody, it's like this is quadrant 1. And if you think about it, if we do radians, that means theta for quadrant 1 is greater than 0 and less than pi over 2, right? That's what it means to be in quadrant 1. However, I'm working on a problem for theta over 2, the half angle. So what I'm going to do is, this is called a two-sided inequality. I'm going to convert this to an inequality for the half angle, which means, you know what I need to do? If I want to get from theta to theta over 2, I have to do the same thing to all three parts of this two-sided inequality. So I'm going to divide all three parts by 2. And then I end up, this is a complex fraction. You may need to review how to simplify complex fractions. But when I do this, I end up with an inequality that says theta over 2 is greater than 0 and less than pi over 4. If I were to go look on my circle, 0's here, pi over 4 is here. So I know the half angle has to be somewhere in there. Now I'm looking at the sine of the half angle. What's the sine? Is the sine going to be a positive or negative number if my angle is from 0 to pi over 4? Well, obviously, all the angles in here, they're all in quadrant 1, and the sine in quadrant 1 is positive. So because of this, I know theta over 2, the sine of theta over 2 is going to be a positive. So now I can say, here's the formula for this problem. Right, I know it's going to be positive. The formula says plus or minus, but because for this problem, I determined theta over 2 is in the first quadrant, and I know the sine in the first quadrant has to be a positive number. So then just to finish this problem, if I plug in 1/8 for the cosine, so once again, now this becomes a problem of doing math with fractions. 1 minus 1/8 is going to be 7/8. If I simplify this complex fraction at 7 over 16, here square root of 7 over square root of 16. So the sine of theta over 2 should be square root of 7 over 4. And I can check on my computer and confirm I didn't make any mistakes. And that's correct. So that's the idea. Let's look at another problem. Let me find one that might be interesting. Well, let's just do this. Let's use the same problem, except I'm going to change the initial conditions. Actually, let's do one. I would do problem 4, but I will write down the information. This one's going to be a little more complicated. So cotangent of theta equals -10. And then I'm trying to think about this because I want to do a certain kind of problem. So all right. So the second condition, I'm going to say is that the I'm going to say the sine of theta is positive. And for this problem, just for fun, let's calculate cosine of theta over 2. So the formula for the cosine of theta over 2 is once again plus or minus square root of 1 plus cosine of theta over 2. Let's go ahead, before we worry about finding cosine of theta, let's figure out where theta over 2 is. So to figure out which quadrant theta over 2 is in, we first have to figure out which quadrant theta is in. The cotangent is negative. That's the same thing as saying that the tangent is negative. What quadrants is the tangent negative? It's actually quadrant 1 and quadrant 4. Which quadrant is the sine positive? Sorry. Cotangent is negative in quadrants 2 and 4. The sine is positive in quadrants 1 and 2. What's the common quadrant? Theta has to be in quadrant 2. And this actually is not going to be what I want. Instead, I'm changing this on the fly because I want to get a certain kind of result. Let's say I said sine of theta is less than 0. Where is the sine of theta less than 0? Quadrants 3 and 4. So now what do I have in common? Quadrant 4. So I want to make this problem such that I'm in quadrant 4. So if you think about quadrant 4 is down here, and we think of it as going from 3 pi over 2 to 2 pi. So if I write my two-sided inequality for theta, it ends up being greater than 3 pi over 2, but less than 2 pi. But I need to convert this now to the half angle. So I divide all 3 parts of it by 2. This ends up becoming 3 pi over 4. And this ends up being pi. So the half angle is greater than 3 pi over 4, but less than pi. Now, where is that? Well, pi is right here. 3 pi over 4 is right here. So theta over 2 is there, which means it's in actually quadrant 2. So we've determined that theta over 2 is in quadrant 2. So that means when I go get my formula for the half angle, the cosine of the half angle, it can be plus or minus. But if I'm doing the cosine, what is the cosine? What does it always have to be in quadrant 2? A positive or negative number. In quadrant 2, which is where my half angle is, cosine is always negative. So that means my formula is going to be negative 1 plus cosine of theta over 2. So now, to complete this problem, I need to figure out what the cosine of theta is equal to and plug it in and go from there. So now I go back. Cotangent of theta is minus 10. I always switch from cotangent to tangent, which means it's the reciprocal. The plus or minus doesn't change. So it's still negative, it's negative 1/10. Now I like to create my right triangle. Now I know from way back up here, I determined that theta is in quadrant 4. So just to remind myself, since this is an actual right triangle for for theta, I know it's quadrant 4. So tangent, so-called TOA, opposite over adjacent. Opposite is 1, adjacent's 10. Pythagorean formula says square root of 1 squared plus 10 squared, square root of 101. What I need for my formula is the cosine of theta. So now that I have this right triangle, what would the cosine of theta be? So ca, adjacent, over hypotenuse. So there we go. Now I can plug it into the formula. And this is one of the problems where it's going to get sort of messy. So we'll just see if I can finish it just to show you how messy this gets. Negative 1 plus cosine of theta all over 2. Now you can't really leave it in this form just because they always want you to simplify. So what we're going to do here now is we're going to have to sort of combine these, what's in the top, into one fraction. And then we'll have a complex fraction and we'll go from there. So really, so you can see what I'm doing, because this is pretty messy. To combine these, I need a common denominator. So I'm going to rewrite 1 as square root of 101 over square root of 101 plus 10 over square root of 101, and all that is over 2. Right? So all I did was rewrite 1 as square root of 101 or square root. Now I can combine these since they have the same denominator, and you get square root of 101 plus 10 over square root of 101, all that over 2. Now it's a complex fraction. What happens is 2 goes up here in the bottom. So square root of 101 plus 10 over 2 square root of 101. Now, normally in the world of math, they don't really like I guess they don't mind when I look at the answer. Well, I guess they don't really, I don't think they like this square root in the bottom here. So what I'm going to do is I'm going to multiply this is where it gets very messy. Actually, I think I might stop here because now this is just a messy math problem. And the main point of this was to try and help you to understand for the formula, do you do the plus or the minus? So let me stop there because that's the main thing I was wanting to explain.